guys, so far we've done ionic bonding, we've talked about oxidation states, how to determine the formulas of ionic bonds, and then also determine the names of ionic bonds. However, this is probably some of the most difficult stuff that we've done so far, just because there's a lot you have to remember and there's a lot you have to practice. So these things are not necessarily intuitive, whereas you can just memorize it because you have to know the process of how to find the charges, how to find all the information. So I just wanted to give you guys the opportunity this morning to practice, and then if you're still having trouble, I have some examples here for you. So I'm just going to go through, I'm going to do some oxidation state practice, ionic bonding naming, and then ionic bonding formulas. So stick around if you need some help and you need a step-by-step process. So the first thing we're going to do are the oxidation states. Now this is the charge based on the ions, so the metals that are donating the electrons to become cations, or the nonmetals that are accepting electrons to become the anions. So if you can't figure out the oxidation states, it's going to make figuring out the formulas and the names to be very tricky. So we just want to make sure we're all on the same page for that. So I have a few examples here. And for each of these elements, we're going to find the valence electrons, determine whether it's going to donate or gain those electrons, and then determine the charge. So I'm going to do all of that at once and then write it on the screen because this annotation feature is not the best. So we will go from there. Alright, so the first one we're going to do here is going to be lithium. So of course, as always at this point in this class, we should probably have our periodic table pulled up as well as our polyatomics. So again, this is just p-table. You guys know how to Google this at this point. But we're going to find lithium. And remember, the way that we find our valence electrons is going to be the group number. So the group number that the element is in is going to be that valence electron. So group number 1 is where lithium is, because the 1 is right here. Again, the groups are the ones that go up and down. Lithium is in group 1, so he has 1 valence electron. So we know he's going to have 1 valence electron. So let me go back here. And we know he's going to have 1 valence electron. Now, is lithium going to donate or gain this electron? Well, lithium is a metal. We know that because he's on the left-hand side of the table. And we know that metals will donate their electrons. So he's going to be looking to donate. He's going to be looking to get rid of it. Okay? Now, the reason for this, again, remember that the goal of every single atom is to be stable. So it wants a full outer energy shell. So for most, that's going to be 8 valence electrons in the outer shell. For those lower elements on the periodic table, those are going to be just 2 valence electrons in that very first energy shell. Because remember, the first energy shell only gets 2, and as long as it's got 2, it's stable and happy. So that configuration of helium. So all metals have low numbers of valence electrons, right? Less than 4 or less. And when they have that low number of valence electrons, it's easier for them to donate them to get to a stable energy shell that's below it, rather than having to take on more electrons. Because like for lithium, to be stable, he's got 1 valence electron. In order to be stable, he would have to take 7 electrons from other elements or other atoms. And he doesn't want to do that because that would take way too much energy, when it would be so much easier to just kick off or give away this 1 valence electron that he does have in his outer energy shell. So we know he's going to donate. Now the charge here, for the metals, the charge will be the number of valence electrons, but for the nonmetals, it won't be. So we need to make sure that we understand the charge and the valence electrons are not the same thing. The charge is based on how many electrons are donated or how many are gained. Here, because we're donating 1 electron, the overall charge of lithium is going to be 1 plus. Because remember, electrons are negatively charged, so if you get rid of 1 electron, the positively charged protons in the nucleus are now going to be the dominant charge, so we're going to have a charge overall of that atom of +1. So we got rid of 1 electron. Charge is the +1 because we're a metal and we're donating. Okay? So there is lithium. Now, let's do oxygen. So oxygen is a nonmetal, so he's going to be a little bit different. So let's go find oxygen on our periodic table. Oxygen is right here in group 16. Okay, so this is group 16 or 6A. This is where I've been noticing a lot of mistakes in some of your classwork. So remember, in group 16, or any of these groups from 13 to 18, when you're looking for valence electrons, you have to drop the 1, okay? You have to drop the 1 from the group number. So if you're looking at it on P table here with 16, a lot of you were telling me, oh, oxygen has 16 valence electrons. No, the most that we are looking at in our outer shell for us is 8. 8 valence electrons is the maximum number. So you can't have 16 valence electrons in an outer energy shell because that's impossible. So we have to drop the 1. So just know for groups 13 through 18, we're dropping the 1 in front of the number. So oxygen, yes, he is in group 16, but we're dropping the 1 so he has 6 valence electrons. Okay? So let's just go ahead and do A6. Now, donate or gain. Well, oxygen is a nonmetal. We know he's a nonmetal because he's on the right-hand side of the table. This is why, everything in physical science with the periodic table, everything in chemistry, it all builds on itself. So if you get lost somewhere along the way, we got to make sure we're picking up all those topics because you can't do one without the other, so to speak. So we know oxygen is a nonmetal because it's on the right-hand side of the table. We know it has 6 valence electrons because it's in group 16, and we drop the 1, so that's just 6 valence electrons. And because he is a nonmetal, and because he has 6 valence electrons, it's going to be easier for him to gain 2 electrons to fill that octet rule. Okay, he's going to gain 2 electrons to fulfill his octet rule so that he will be stable. So since he is gaining electrons, we know his charge is going to be negative because electrons, again, are negatively charged. And if you are gaining electrons, you're going to be left with a negative charge because you're taking on more of those negatively charged subatomic particles. So now if oxygen is gaining the electrons, we know it's going to be negative. Here is where this is different from the metals. So the metals, their valence electrons, when they kick them off, that's their charge. For the nonmetals, you have to pay attention to what the number would be that fulfills the octet rule. Okay? So here we've got 6 and we want to get to 8. So the charge here is the number that it's going to take to get to 8 from 6, right? Because we have 6 valence electrons. We want to get to 8, so we're going to take on 2 electrons. So the charge is -2. So for these nonmetals, when they're donating, if you want to figure out what the charge is, just remember it's 8 minus the valence electrons because we're trying to get to 8. Okay? So that would be oxygen. And let's do one more. Chlorine. Let's take a look at chlorine, another nonmetal. Chlorine is a halogen. It is very reactive. Here's chlorine. So chlorine is in group 17. Does that mean we have 17 valence electrons? No, sure as heck doesn't. Chlorine is going to have 7 valence electrons because now we know for sure that we dropped the 1 in front of the group number, so 7. Now, if you see the group number as 3 through 8A, if you see the A, that just means the 1 has been dropped for you. So, again, chlorine is in group 17 or 7A. It's got 7 valence electrons. Chlorine is a nonmetal. Again, we know because it's on the right-hand side of the table. And we know that chlorine is going to gain electrons because it is a nonmetal. It's going to form an anion, which is negatively charged. And figuring out the charge, we know it's going to be negative because it's a nonmetal. And it's going to form an anion. But here we have 7 valence electrons. And again, just like with oxygen, we're looking to fulfill that octet rule. So 7 to 8, it's going to take 1, right? 8 minus 7 is 1. So the overall charge of our chlorine is going to be -1. Okay, and it's essential that you be able to do this in order to get the correct charges for your metals and your nonmetals when you're doing ionic bonding. There are periodic tables out there that do have the charges above the groups because, of course, like chlorine is a halogen. All of the halogens, all of the elements in group 17 are going to have a -1 charge, always. So there are periodic tables, and I've given you tables before that have the oxidation states above them, so the charges on them. But the thing is that a lot of times that can be confusing because students start to confuse the charges with the valence electrons. And remember, especially for those nonmetals, they're not the same thing. So we got to just make sure where that charge is coming from. So you need to understand where the charge is coming from, so that way you don't get confused between the charges and the valence electrons. Okay? So hopefully that helps with any confusion that we've been having. And then, of course, if you're still worried or have questions, you can absolutely let me know.